Okay, so this is Mathematics Paper 2, 2022 from the grade 12 syllabus D. So this question is also under geometric progression. It came on question 3b. It is saying, given that the third and the sixth terms of a geometric progression are 3 over 4 and 3 over 32 respectively, find the first term and the common ratio, then find the nth term, and then we find the sum to infinity of the progression. So at this point we were told that the third term and the sixth term are 3 over 4 and 3 over 32 respectively. So when they say respectively, it means the one which was mentioned first gets the first value, the one which was mentioned second takes the second value. So we're going to use this information to calculate the first term and the common ratio. Okay, so we're starting. So from our data there, we were told to find, we have T3. So from the previous video, I said if you are finding T3, it means your power of R will be less to this number by 1. So T3 will be given by that. Then we shall just take this part and say this is our T3, which was equal to 3 over 4. And then the other information that has been given is for T6. So T6 also is going to have a R power 5. Then we shall just take this part and then say it is the one which is equal to 3 over 32. So if you remember properly, I said this one, AR power 2, can be written as A times R times R. Then this is the one we're saying is equal to over 3. Then this other one, A R power 5, it can also be written as A R R R R R. Then it is the one which is equal to 3 over 32. Then this guy which is here, it can be replaced at this point here. So it can come here. So when that happens, it is the same one saying, we remember that ARR is equal to 3 over 4. So at this point, we are going to remove this, and then we are going to say, we will replace this point here, but its value is 3 over 4. So we're going to say 3 over 4 is the one which has taken this place, and then since we had the 5 R's, we have now remained with 3 of them. So it is R power 3. Then it is equal to 3 over 32. So just to rewrite this part, it can also be written as 3, then R power 3 over 4. Then we have 3 over 32. So there is another rule which says if the numerators are the same and you are just having one fraction, then it is as good as ignoring those two. So we are just going to ignore the top 3 and 3, because after cross multiplying, for instance, if we cross multiply, it will be 3 R power 3 times 32, which is equal to 3 then times 4. So you can see that we can divide off a 3, we can also divide off a 3. So whenever I've got one single fraction and one single fraction, then you see that they have the same numbers. It is as good as just ignoring those numbers. So at this point we shall ignore this and say R power 3 over 4 is equal to 1 over that, because we have divided off those. Then we cross multiply. So this one will cross multiply with that one, this one will cross multiply with that one. So it will be r power 3 equals, this guy will cross multiply that one to be 4 over this one. We know that even after cross multiplying we're going to divide it, so we just ignore its cross multiplication, then we are going to yield that. So just to repeat this point, I know I have to cross multiply, but afterwards again I'll be forced to divide off this 32, so I just leave it to be there and just cross multiply the 4. So that's what we have at that point. Then just to rewrite it, we have 4 over 32. Then we know that 4 can go into 32 and it can also go into 4. So 4 there and 4 here. So 4 there is 1. 4 into 32 it is 8. Then at this point we can say this. Then if a number is below a 1, it is as good as that number to its power in a negative form. It's good as that number to its power in a negative form. So at this point we have, then we can change this 8. 8 can be written as like that. So we shall replace 8 then like that. So okay, pardon. So that is what is there. Then this is as good as say, okay, just to go back to this point, which was like this. It was as good as finding the cube root, which was this one. So we cancel out r equals, then it will be 1 over like that. So that is it, the answer we expect. So at this point we are going to ignore the 3's, which is giving us 2 like that. Then we know that this can now be written as 1 over 2. So that is the value for r. Then from there we can get back to the solution of finding a. So to find the solution for a, we are simply going to come here where it was simpler than going this point. So you can use t3 equals this one rather than this one. So that's what we are going to rely on. So we are going to say t3 was equal to ar power 2, which was equal to 3 over 4. So we are just going to get this part. So ar2 equals this. Then we know that we have found our r to be 1 over 2. So we replace our r there to be 1 over 2. So a, then we replace our r to be 1 over 2. Then we have that. At this point we know that if you have got a fraction and then that fraction is given a power 2, it means that a times it and also that b times it, like that. So at this point it is 1 times 1 times a, which is a. Then down it will be 2 times 2, which is equal to 4. Then like that. So that rule again which I told you, whenever you are having same denominators or same numerators, ignore them. So at this point we have a single fraction and a single fraction, then we have the same denominators, hence we divide them off. So we're just going to say a equals 3. So in this case we have managed to find the first term and the common ratio. Therefore 3 is first term and 1 over 2 is common ratio, which is r. Then if we get back to our question, there is also this question which is saying find the nth term. So to find the nth term, we simply get the formula for finding any term of a GP. So to find any term of a GP, we use this formula. Then from our calculations from question 1, we can say a was equal to 3, then r was equal to 1 over 2. So we are going to replace these two and simplify. Then that will be our nth term. So nth term is the same guy, but just replace a and r values and then simplify. So it's tn equals, then we replace on a there, and then we also replace on r, like that. Then from there, we know that we cannot multiply something that has a power, so these three will wait, so it will be like that. Then this power is coming as a result of these two being, since we are subtracting them, it means they were being divided. So this guy had the power, which was n, then it was divided by the same guy. So that's what it means there. Since there is a minus, it means this power was for both of them and they were being divided. So from there, we'll start with this guy, which is here. Then the 3 follows. Then this guy swaps. It was 1 over 2, it becomes 2 over 1, or just a 2. From there, this will remain, and then we multiply to get a 6. Then we know that a number should be in front, so it will be 6, then 1 over 2 power n. So that is our Tn. So in simple terms, or a shortcut, if you have been given the way it was, Tn equals like that, then 1 over 2 n minus 1. So in simple terms, just get this one and multiply it there. So that's the case. If you are looking for a proof, you can just say this number times that one. Whatever number will be there, as long as it will be 1 over that number, you just multiply whatever number will be there times this one. So in this case, 6. Then ignore this negative 1 and just rewrite it the way it should be. So that is a shortcut for this part. Okay, after being done, so this is the nth term. So the nth term formula should contain n in it, and the other terms simplified. So now let's go to the last question, which is saying the sum to infinity of the progression. Sum to infinity of the progression. So sum to infinity can only be found if r is less than 1, and the formula is given by this, where we have a was equal to 3 and r was equal to 1 over 2. So sum to infinity equals, our a is a 3. I understand it should be like this, this one, but for the sake of being fast or avoiding mistakes, I like using division. If there is over, I will say division, then whatever is down, I'll put them in bracket, and on the other side it is the same, because this guy is the same as division. Then from there it will be 3. I will maintain this guy and then say, remember the shortcut in the silent video? So there's a silent video just below this one, there's a silent video. So it says this one multiplies with this one, you write your answer, then follow the symbol which is there, and then the number which is on top, then over the same denominator. So I'll repeat, this number will always multiply this one, which will be a side, you write the answer, follow the sign which is there, and then write the number which was on top of this number, and then over the same number which was multiplying. Or we can use our common calculation, which is saying common denominator, then 1 into 2, 2 times 1, 2, minus 2 into 2, 1 times 1, 1. It's the same answer. So all of them will give you the same answer. Then from there, we can continue with our sum to infinity. This is 3 divided 2 minus 1, it's 1 over 2. Then we know that it is known that if it's division and you change it to multiplication, these numbers swap. So it will be 2 over 1, meaning 3 times 2 over 1, which is 6. Okay, this marks the end of the video. Thank you very much for your support and your time. See you in my next video.